Office of State Climatology, or the State Climatology Office, uh, talks about climate change in Minnesota. And we are going to use some specific instances of information and data that are more local to the Leech Lake area. And so hopefully that will be helpful. But a lot of what I'm going to present is kind of a statewide assessment of what's going on. Before we begin, it's probably helpful to know that when we talk about climate, it's not a one-size-fits-all approach. It's not that, we read the news, we live in a big world, and it is an interconnected world, absolutely. Things that happen on the other side of the world affect us here and vice versa. However, when we talk about what's happening in the climate, which is really a kind of larger picture example of what's happening with all of the weather of all of the places all over the world, what we have to remember is the things that we experience here are not necessarily the same as what happens in other countries or even other parts of our own country. Minnesota and the region that we occupy is is kind of special climatologically. We are in the middle of a continent. When the winds come from the south, it gets warm and it gets humid because we bring in air from the Gulf of Mexico. And the winds blow from the north, then it gets cold and often very dry and sometimes stormy. So you get winter storms. So a simple shift in the wind direction makes a big difference in our weather. And I think everybody knows this probably on the call. But if you think about the difference between that and if we were in, say, Hawaii, or if we were in even Seattle, or a different part of the country or a different part of the world, if we were more surrounded by water, then a simple change in the wind direction maybe wouldn't have the same consequence for them as it does for us. And this is all important because as the climate has changed, the way that every place has changed really differs. And so in Minnesota, we have symptoms that you wouldn't necessarily see in Hawaii or in other parts of the continental United States, and certainly in other parts of the world. And at the same time, when we hear about climate change, when it makes the news, if it makes national news, they're often reporting on things that maybe don't seem so relevant here, even though, again, it's all connected. We might hear about rising sea levels, which it's hard to see how those affect Minnesota directly if you're living inland in a forested area, for example. Or we might hear about gigantic heat waves that are affecting India or parts of Northern Europe. And those have become fairly common in those areas, or even in California. And the question we have to ask is, okay, are these global observations matching the observations that we have here? And of course, the reason that difference is important, and the reason that question is important, is because we all work with, live with, and manage resources that are right here where we live. The other piece that I like to mention is when we talk about the climate, we have to remember that there can be two things that are ongoing at the same time, even though they seem different and they're often confused. And when people get in arguments about climate change, it's usually because of someone's misunderstanding this fact. And so when we talk about our climate having variability, we're just talking about variations, or what you think of as regular ups and downs in the way that our weather behaves. So an easy example of this is that if you were to describe, or if I were to describe winter to somebody who had never been to Minnesota, I would say, well, our winters are usually pretty cold and pretty snowy, and sometimes they're very long. But if they were to then ask me, is every winter like that? Well, then I would have to say, no, no, not at all. Some winters are much warmer than I would expect, and some winters are colder. From one year to the next, 2 winters may be very different. One might be very snowy, and another one might have almost no snow. And those variations, ups and downs, whether you're talking about snowfall, precipitation in general, or temperature, those are part of our climate and probably have a lot to do with just where we are, because we are between, the Atlantic and the Pacific Oceans. We're right in the middle of the continent, and we're halfway between the equator and the North Pole, and we've got Canada and the tundra off to our north. So we have these routine or normal variations that are part of our climate. So we will always, no matter what happens, we will always have periods where it's warmer than we're used to, or drier than we're used to, or wetter than we're used to, or colder than we're used to. And this is just kind of how our climate works. At the same time, though, we definitely have what we call trends. Trends would be when we can detect using statistics, and the statistics are applied to measurements that we have made, when we can detect some kind of an important, persistent, or long-lasting change in the way that our climate behaves. And I'm going to be talking to you today about our trends. In other words, what are the important and long-lasting changes that we're already seeing in our climate? And the reason people get confused about this is because they think, well, if we're getting warmer, then maybe that means we should never have a cold day again, or we should never have a cold winter again, or if it snows, that must be proof that we're not really getting warmer. And in fact, that's not really how these trends work. We still have ups and downs in our climate. We still have warm periods and cool periods, and we always will, even as these trends continue. But what we do know is that a typical winter now, or a typical year now, tends to be warmer than if we had looked at the same types of observations 40 or 50 years ago. So it's really in the last several decades that we've started to see very sharp changes. And we know from as much information as we have, these are some of the fastest changes that we have observed in the historical record, using observations, using the kind of modern instrumentation. But then when we look at evidence from the deeper past, it appears that these are also some of the fastest changes that have been that we can detect on this continent, possibly for thousands of years. So that's to say, our climate's always going to have warm and cool periods, and it's always, and by periods I mean weeks or months, maybe even a cool year. It's always going to have wet and dry spells. But we are seeing systematic, persistent, long-lasting changes in the way our climate behaves. So let's talk about the two main things that we are seeing. In Minnesota, and this is really, we're talking about Minnesota, and I'll let you know that some of this is true, uh, a lot of this is true throughout much of North America and throughout much of the world, but not all of it. So the first thing that we're seeing is increasing temperatures. We are getting a lot warmer, and I'm sure people on this call have observed this, or they can talk to people in their family, and through stories you probably know it just used to be a lot colder, especially during the winter in Minnesota. And this is not to say that every single winter is warmer than the winter before, or that every year is warmer than the year before, but that when we look at how most years are now, they tend to be warmer than the years of the past. So we're seeing increasing temperatures, but we're especially seeing this at night and during winter, and when we think of it being really cold. Well, you might think of this as it's a cold weather warming. This is where it doesn't mean that we never get hot, or that we're not getting hot also, but our main symptom right now that we see in the data that we use is warming during the winter, a kind of a shrinking of what we think of as winter, and winter generally becoming less severe in terms of cold, and warmer conditions, conditions where things can grow, taking up more and more of the calendar. And we already see that cold extremes are less common and also less severe. Again, not every single year, but more years than we used to have. We would be almost devoid, or they'd be absent of true extremes of cold weather. This past winter was one example. We had a couple good cold days, but nothing like what used to happen just 50 or 60 years ago with high frequency. The other main symptom, and it's interesting in the Leech Lake area because it's not as strong as in other parts of the state, so I changed the order that I'm presenting this information. But most of Minnesota, most of this region has also gotten a lot wetter with more precipitation and more snow and bigger floods, more frequent and larger precipitation extremes. When we average all the information we have around the state of Minnesota, uh, this is a very clear trend. And I'm going to give you some examples of this. But it does appear like it might be a little bit less noticeable in the Leech Lake, Band of Ojibwe areas. And so I'll be interested to know if people have any observations about what's happening in your area, because again, on a statewide level, we see, well, the average precipitation in Minnesota is increasing, but when we look closely, there's a few exceptions, and you might be in one of them. So I'll be really interested um, in hearing your thoughts. However, the projections indicate that even if you haven't gotten really wet yet, it's probably coming. So prepare for more precipitation. The projections also indicate that, with normal ups and downs in our climate, we would expect to keep losing the really cold conditions in winter. In Minnesota, using the data that we have, we actually see that we're not getting more extremes of heat yet, that you can still look backwards 4 or 5 decades or even longer and see periods in history that were hotter during the summertime and had worse heat during the summertime. And we believe that even if we went back beyond the instrumental record, we would see even more examples of devastating summertime heat in Minnesota. So those right now are not yet affecting the state, or they have not yet gotten worse. However, the computer models that are used to help us understand what the future climates might look like tell us that we will start to see more extremes of heat by, say, the middle of this century. We don't know exactly when that would begin, and it would be, the models only help us. They give us some guidance for understanding, but they don't give us 100% certainty. The same is true for drought because most of Minnesota has gotten wetter. And even in northern Minnesota, even in the Leech Lake area, we have not seen worsening of drought conditions over the historical period. So there's still definitely drought and there are definitely dry times. But when we talk about climate change, if we're asking the question, is this change, or are we seeing some kind of a change in the frequency of drought? We're also looking, has it changed beyond something that we would have observed historically? And with both heat extremes and drought, the answer is no, uh, to the best of our ability to tell. However, as summers start to get hotter later in the decades ahead, we would also expect that would dry things out more, and you might end up with more drought by that time. So possible increases in drought by the middle of this century, even though we have not observed those on a statewide basis yet. And the tornadoes and the big hailstorms and the big straight line windstorms that knock down trees with thunderstorms, those have not yet shown any indication that they've gotten worse. Although, we should point out, and everyone on this call knows this, that severe weather, those big thunderstorms and the hail and the strong winds and even the tornadoes, that's all part of Minnesota. That's always been here. And just like the normal ups and downs in our climate, it will probably always be here. So again, we already have to deal with them. It's just that when we look at them scientifically, they don't appear to be getting more common. They don't appear to be getting stronger. But they already had a pretty good start. They were already pretty common and pretty strong. So let's just start looking at how our conditions are warming. So the first map I'm going to show you is just the average annual temperature changes in Minnesota going back about 125 years or so. And you can see that Minnesota's on average warmed by about 3 degrees. It's warming faster in the northern part of the state. So people on this call have faster warming in their areas than some of your friends down in far southern Minnesota. But the whole state is warming. The average is about 3 degrees Fahrenheit over the last 125 years or so. However, when we look at how that warming is distributed across the season, across the calendar, it's really interesting. We see much faster warming during winter time. So here when we talk about winter, we're using the climatological winter or meteorological winter. So that's December through February. Obviously, the season winter, the experience of winter is much longer most of the time. It goes from sometime in November to sometime in March or even April. But the seasonal winter is December through February. And when we look at low temperatures for every day of that winter season, for every year beginning in 1895, going right through through last year, we see a very strong warming of the nighttime, those overnight low temperatures, about 7 degrees Fahrenheit of total warming. So that means the average night during the wintertime is now 7 degrees warmer in northern Minnesota than it was when we started taking good observations in Minnesota. And you'll also see on that map that the warming is stronger in northern Minnesota again than in southern Minnesota, but it's still, that's where the time of day and time of year that we see the most of our warming. Now, if we look at summertime high temperatures, it's a different picture. There's still a little bit of warming in the high temperatures in summer in the northern part of Minnesota, but it's not as strong as the warming of those wintertime low temperatures. And in fact, in central and southern Minnesota, it's hard to know if we're actually warming at all during summertime days or if we're cooling a little bit, which is what we see in southern Minnesota. Again, all of the science tells us that in the next 20, 30, 40 years, we're going to start seeing hotter summer days. It just is through this point in Minnesota, we have not observed that, not strongly anyway, and certainly not in the way that we've observed the dramatic warming of wintertime nights. So now I want to show you something, if we have the time, we'll get to this in a little more detail. But on the map on the right, I'm using a tool that we have at the DNR that we made in the last year. And you can actually select whatever area you want. And you could use watersheds, you could use counties. We do have some state forests on there. We currently do not have tribal lands, but that is something we could probably add. And then you just select the area that you're interested in, and you can choose more than one area as long as they're touching. And you can graph out all kinds of climate variables and see how they have changed over time. So this first graph that I have is just the annual average temperature for the two watersheds that kind of encompass the Leech Lake Band of Ojibwe lands. And and you see all the ups and downs in average annual temperature across that area going back to 1895 and right up through 2019. This purple line that you can follow along here, that is a trend line showing the warming or showing the temperature change for annual average temperatures since 1970. This is about when we started seeing really sharp warming in Minnesota. And you also can see from the key here that that corresponds to an increase of about a little over 6/10 of a degree Fahrenheit per decade. Well, this is a 5-decade period, so it comes out to about 3.1 degrees Fahrenheit of warming in this area just since 1970. If you go back to this map, that suggests, in this area here, that almost all of the warming that we've seen since 1895 has really occurred in the period since about 1970. This is when we've seen most of the warming in the region. But that's just the annual average temperature. So that's every single day averaged through every year, and then just looking for the change. If we get a little more specific, again, those summertime days, the average high temperature between June and August, or June, July, and August, has really only risen kind of modestly by about a total of 6/10 of a degree Fahrenheit since 1970. So on the two maps back here on the right side, we saw not a lot of summertime, especially daytime warming, a little bit, kind of subtle, and that's again confirmed on this graph. By comparison, when we look at our wintertime nights in the area where most of the people on this call live, very fast warming. Every decade has seen over 1 degree of warming of winter nights since 1970, and that totals over 7 degrees. So almost all of the wintertime, nighttime warming that we have seen in the region has really just been in the last 5 decades. So when we talk about a really fast changes, this is what we mean. It's the amount, just to put this in perspective. So I don't know if you guys can see where my cursor is on the map, but I'm kind of holding it over where most people live. If we to warm by 7 degrees Fahrenheit in 50 years, that's the equivalent of if we had gone into Iowa towards about the Des Moines area, right where my cursor is now. That's the amount of warming that we're talking about. So in 1970, the temperatures in Des Moines, Iowa during winter time, night times, are about as warm as they currently are in the Leech Lake area. So dramatic warming. Here's another way of looking at it from a statewide basis. We just take on the right the 30-year average of the wintertime low temperature in Minnesota, and we can see we're kind of, again, right up in this area here under my cursor. And these are the average low temperatures during winter in this region. So between, right around 0. An average winter night should be pretty close to 0. Some nights are going to be warmer and some nights are going to be cooler. But that's just a 30-year average that ended in 2018. If we look at the previous 30 years, going from 1959 through 1988, the values were 5 degrees colder. So again, we've had dramatic warming in a very short amount of time. Another thing we can look at is, it's not just the whole season, but let's look at individual nights. And there are decent observations at both, there's an observatory at Leech Lake and also one at Winnipegashish, but the probably highest quality climate station in the general area is from the Grand Rapids Forestry Lab in terms of having consistent measurements. And when we look at this one, here we're just tracking the number of days per winter or per year where the average, or where the low temperature for some night falls to -20 Fahrenheit or lower. So not even an extraordinarily cold night for northern Minnesota, but a pretty cold night for northern Minnesota. And what we see on the left, these are the 1930s, 40s, and 50s, when it was common for the Grand Rapids area to have anywhere between 15 and maybe 30 of those nights where the temperature falls to -20. By the middle to later part of the 20th century, instead of 15 to 25 or 30, we were down to more like 5 to 20. And now we're kind of at all-time lows. And we've had some years where the temperature barely, maybe you only get one night that's that cold. And as recently as 2020, we only had a single-digit number of nights that were that cold. So we're part way. Obviously, we still have the next side of the next coming winter to keep counting, but uh, this was a fairly mild winter. So, and these kinds of changes have, and I don't probably need to tell everyone on this call, but they have a profound impact on the natural world, because it's not just that cold is temperature for measuring only, but it actually it has a lot to do with the setting that um, a lot of our species exist in. So in Minnesota's forests, where we have the nice tamarack trees, the there's also that eastern larch beetle that's always been there and has a nice relationship with the tamarack trees, eats some of the bark, but there's always been uh, enough survival of those trees. Now, when winters are warmer, the eastern larch beetle doesn't go dormant, and so now they eat more and more and more and more of those beautiful tamarack trees. So we're seeing some loss of our ecosystems and some changes in the natural world just because it doesn't get as cold as it used to get. And obviously, if winter's getting warmer, one of the things that we're seeing, and this is at Duluth, but we're seeing this across Minnesota, where there's more days between November and March when we normally would see snow falling, where instead of snow, we have rain. So we have either rain falling or we have snow that's falling, but it's melting right away because the temperatures are way above freezing. And you can see from the 1950s on the left through the 60s, 70s, right up to the 2010s, more and more and more instances each year or each decade of days where there's liquid precipitation falling during that longer the winter that we experience, the November through March. So with more liquid precipitation falling during winter and warmer winter conditions, you also know that that means we have less time where there's a lot of snow on the ground. So this is changing the relationship between the ground and the snow and the things that rely on the snow, because we're still actually seeing a lot of snow falling. That hasn't changed very much in Minnesota at all. In fact, some places have gotten snowier. But now when the snow gets onto the ground, it doesn't stick around as long because you've got warmer air temperatures, or you have liquid precipitation. Either one of those, and especially in combination, those can melt the snow, and those start to deteriorate that large snowpack that we used to experience for the entire winter. And now, sometimes it's there and sometimes it's not. There are some years where we hardly have any snow except for maybe 1 month or 2 months, which is a much shorter period of time than we were accustomed to. Another thing that is changing, these are all these diagonal lines just show over time what has happened to the length of Minnesota's ice season on its area lakes. And so the higher you go on this graph, the longer the ice cover season is on Minnesota lakes. But on average, we've lost about 12 days in the last 3 decades of ice cover on a typical Minnesota lake. So we still get really cold years sometimes, and we'll have a nice long ice cover season. But when we average those really cold years with the increasing number of really warm years, what we see is that we're losing our lake ice season slowly. So loss of 12 days in a year is a pretty big deal, and it changes the amount of time that you can be on the ice safely and it changes the conditions of the lake ice too, and that also affects the fish that live in the lake and everything else that depends on those conditions. So we are seeing some really big changes in Minnesota just because of warming winter conditions. Uh, so 2019 was the warmest year on record in Minnesota. That's when we average everything around the entire state. So this is every single year of annual precipitation averaged around the state of Minnesota. And you see way up at the top there is 2019. What you also see is that the 2010s around the state of Minnesota were the wettest decade that we have on record back to the late 1800s. Uh, and so it wasn't just the very wet 2019, it was that there were other years that were really wet too. I just want to point out though that when we look at the Leech Lake area, this is just a different graph, but it's showing the same thing. This is annual precipitation right up through 2019. You do see that 2019 in your area was a little bit wet. It was wetter than this purple, the values for precipitation are above this purple line, and that purple line is the average. And we're just drawing the average precipitation for the last official normals period, which is 1981 through 2010. But the way you can interpret this graph, if you look left, you see that there were lots of years that were at least as wet as 2019 or wetter. So it was a wet year, but it wasn't the wettest on record. And in fact, you can see that for your area, the wettest years on record are still, in the late 1990s or at the beginning of the 20th century. So this was far from the wettest year on record in the Leech Lake area, even though, it was the wettest year and the wettest decade in the kind of averaged around the rest of Minnesota. This is an animation that's going to show how the average precipitation in Minnesota has changed. I've just drawn a kind of bad circle roughly around the Leech Lake area. This begins at the beginning of the 20th century, and these are 30-year averages, and they're just moving forward year by year. And this blue line represents where the average annual precipitation is 26 inches. And you can see a lot of back and forth in that blue line. But what I want you to notice are the red areas in northwest Minnesota and the blue areas in southeastern Minnesota. And watch how those really change in their shading towards the end of this animation. So what you see is that in the Leech Lake area, it's gotten a bit wetter, although some of that kind of change, not as dramatically in other areas, but that 26-inch average precipitation contour did move about 75 to 100 miles to the northwest. Southeastern Minnesota has been getting wetter and wetter, and the basic trajectory has been for Minnesota to get wetter from the southeast. And again, if you just watch this one more time, you'll see that these dark reds that you see at the beginning of the animation, they eventually lighten and turn into lighter reds as even the dry parts of Minnesota get a little bit wetter as this wetter climate gets imported from the south and east. And again, you can watch the blue areas in southeast Minnesota, and you can watch the red areas get lighter in northwest Minnesota. I wish I could speed this animation up, but it's a frame by frame, a GIF or GIF. So this particular image shows, we've got two. So one is, down in the Twin Cities in 2008 and 2009, a lot of the residents were concerned because our lake levels were dropping. They were dropping pretty fast. And so the climatology office made a map to show, well, what's happened from June of 2001 through mid-August of 2009. Let's look at the total precipitation, and then let's see if it was dry or if it was wet. So the orange and red areas were dry, and the blue and purple areas were wet. And what we saw is it was very dry over southeastern Minnesota, but at the same time, it was very wet over northwestern Minnesota. So, we don't all have the exact same climate at the exact same time. Now, more recently, the southeastern part of Minnesota has been very wet, and really from parts of the North Shore right over towards Brainerd down to the Minnesota River and then into far southeastern Minnesota especially, where there's been almost an extra year to year and a half of precipitation. But at the same time that this region has been wet, the northwestern one-third or so of Minnesota has been pretty dry. And so this is why we say, it was a wet decade on average across Minnesota, but when we look specifically, it was a bit drier, not too far from where a lot of people on this call live. One thing that has changed almost everywhere, even if the years haven't become a lot wetter, we are seeing more days where there's heavy precipitation. And so the next three graphs just show you how many days are there in a typical year where you have 1, or you have 2, or you have 3 inches of precipitation. And we know across the state, the number of days with an inch of precipitation, which isn't a flood, but it is pretty heavy rain, or if it's snowing, it's pretty heavy snow. Uh, those have increased by, depending on how you look at it, about 20 to 40%. So there's 20 to 40% more days with an inch of precipitation now than there were at the beginning of, say, the 20th or the middle of the 20th century. 2 inches of precipitation does cause some flooding, especially if it's been really wet. And we've seen that those have increased by 30 to 50%. So days where you get 2 inches of precipitation are now 30 to 50% more common than they were historically. And the days with 3 inches of rain, and that's where you're really starting to see a lot. It's not necessarily the heaviest rain you'll ever see. You certainly will, in most of our lifetimes, we'll probably see a day with 5 or 6 inches of precipitation. And usually there's really nasty flooding with that. But 3 inches is a lot, and usually when you get 3 inches of rain, lakes come right up to some of their highest levels, streams rise out of their banks, you start to have flooding and erosion and all of those problems, and those have increased. The number of days with 3 inches of precipitation have increased by 60 to 90% in Minnesota. And when we look at the kind of rainfall that's supposed to only come every 10 years or even every 100 years, both of those metrics are now as more common than we've ever measured. So we're seeing more 10-year rains and we're seeing more 100-year rains than we've ever observed using instruments in Minnesota. This image, although it's a little bit south and east from the Leech Lake area, but in 2016 there was a huge storm. And so on the left, you see the radar, and on the right, you see the map that we made showing how much precipitation fell, where areas in, say, in the Brainerd area and down towards Mille Lacs County, they had over 6 inches of precipitation. And when you get that much precipitation in a day, you end up with, here's kind of a before picture from Moose Lake from a different storm, but this was a big storm where it ends up flooding something that had been very familiar. Or in Duluth, here's a before, here's an after. When you get that much precipitation, it doesn't just affect the natural systems, but the flooding can be very damaging to things that we've built also. And it's not just that Minnesota, and again, I understand that not every single part of the state has gotten wet in the same way, but in general, when we look at the future, when we use the climate models that help us understand the future, Minnesota is projected to keep getting more precipitation. Here in the northern half or northern third or so of the state, the general indication is that by the middle of this century, average precipitation will have come up by another 1 to 2 inches. So the same kinds of changes, the same kinds of increases that we've observed already would basically continue. So if it feels like it's gotten wet, if it feels like sometimes it rains harder than it used to, those trends will continue into the future, into the decades ahead, even though we have to remember there's going to be ups and downs. We're still going to have dry periods and we're still going to have drought. This next map, which looks very similar, shows pretty much the same thing. It's just showing how many additional days with heavy precipitation do we expect in Minnesota, where there's, an inch and a half or more of precipitation in the Leech Lake area. And that would be an additional, on average, by the middle of the century, an additional day or so in a typical year. But of course, because we're going to have wet years and we're going to have dry years, that means that some years we maybe won't see any of those rains, and then other years we might see many of them. And then meanwhile, just a quick look at the things that haven't changed so much. We have summertime high temperatures. So this is just a graph, and there's no real increase towards the end. I'm wondering if I can move. Do you guys, if you guys are seeing there, I'm gonna move that out of the way. So if you look at this graph, the most recent year in Minnesota, 2019, is right under my cursor, and that just shows the kind of summertime heat that we're seeing right now. The hot days and the high temperatures during summer really do not stand out and do not show that they've gotten much worse or much hotter. I did circle a good hot year in 2012 there, if you see that kind of flashing circle right up here. And that's just to show, using this graph, if we look backwards in time a little bit, it was a hot year, but it didn't really stand out historically. When we look at the extremes of heat, this graph here shows the hottest days of summer at a town in western Minnesota called Milan, where we have really good observations that go back for over 100 years. And just telling us here that the hottest days of summer, if we saw more values up here higher on the graph, it's the hottest days of summer are not getting more common or a lot hotter. And we're seeing this pretty much across the entire state. However, on the right here, on the right, we have what the computer models, the same ones that showed us getting more precipitation, what they expect in terms of summertime heat. These are days with high temperatures above 95 degrees in Minnesota. In the Leech Lake area, that probably happens on average once a summer right now. And most of Minnesota by the middle of the century would get an increase by a factor of 2 to 3 in the number of 95-degree days. So maybe instead of having 1 or 2 days per summer on average, it would be more like 3 or 4 days per summer. And this map from the same models just tells us that drought is not yet a big part of our climate in terms of changes. I mean, it's part of our climate naturally. We have always had very dry cycles, and they play an important role in our natural systems, but they have not gotten worse or more severe or more widespread yet. When we get into the future, next 20, 30, 40 years, according to the best information that we have, it looks like some of our longest dry periods might be getting longer by a day or two. And if you combine that with more intense summertime heat, that would increase the chances for drought at that time, even though, again, we've not really seen that in Minnesota yet. So to summarize it, we've gotten wetter in Minnesota, although again, more so in the southern parts of the state than say in the Leech Lake area. But the Leech Lake area has definitely gotten a lot warmer, and that has been driven by more frequent and heavy, the wet conditions have been driven by more frequent heavy precipitation. The warm conditions have especially been driven by warmer winters and the loss of those really cold extremes. And then when we look at the projections, they indicate that both of those trends are going to continue. But remember, even as we keep getting warmer and as we start inching towards wetter conditions too, we're still going to have years that are, above where we expect to be in terms of temperature or precipitation. And we're also going to have years that are below where we expect to be. And we have to remember that even if we get very, very wet, drought will always be part of our climate. Those tornadoes and strong thunderstorms will always be part of our climate. And even though hot weather has not gotten worse yet, we do expect more hot weather in the future based on those climate projections. So Melinda, that is what I have on climate. I assume I don't see a clock here.
But yeah, me popping up means we'd like the summary and leave a little bit of time for questions.
Okay, good.
So yeah, thank you so much.
Sure. Should I stop sharing the screen? Would that be easier, or?
Oh, I think you might. I think we're going to have questions via chat. So if
Hmm.
anybody wants to pop in there, I know that there was a couple of students that had a question. And if you're shy, you can send it to me privately and I can share with Ken, or you can send it to the whole group. But one question I had while we wait for the people to type is when we're looking at the confidence of the 50-year trend from 1970. Now obviously your R squared is really low. It's not a good fit. But how certain are we that this is outside of the realm of natural variability?
Wow, that's a really good question. Thank you for that question. So yeah, so our R squared, so basically our how much of our the change can be explained by random variations versus by what we by in this case it's just time. Um, Most statistical tests that you run going back to about 1970 on things like temperature are strongly significant at so your p-values, well, depending on whether if you're using an alpha or a p-value, 0.95 or 0.05 pretty easily with a lot of that, because the connection, that the changes with time are so strong. And this is especially true if you do things like you separate a before and an after period and you just compare what happened after with what had happened before, and you're using something like t-tests. In terms of natural variation, I mean, the one thing that scientists never really know is before they started taking records, what was it really like? What was the hottest day? What was the warmest day of winter? Um, how cold did it get? How wet was it really? I mean, we can use approximations from pollen records and tree rings and things like that, but you don't ever really get those answers the same way you do with the kind of precise measurements that we have now. So there's an element of that we can't answer, but we do know that as well as we think we understand the climate system, that it usually responds most firstly to the sun, and then secondarily it responds to changes in ocean temperature and changes in ocean circulation and the way that the different air masses around the world are directed. And when we have in the past, when we've gotten really warm, it's been because the sun has either actually intensified or because it has appeared to have intensified because we've been able to receive more of its energy. And then when the Earth's climate would cool, it was because the sun had weakened or because it had apparently weakened because we were not able to receive as much energy because we were at the angle the angle of our axis had changed, uh, or we were in a different variation in the Earth's orbit around the sun. But now, with the warming that we're seeing, um, it's it's corresponding with a time where the sun's output is pretty low. The sun is actually pretty weak. And if our climate right now were being driven only by the sun, our temperatures would be getting lower. They would be dropping, and they would have been dropping for a few decades. And they would be entering a period right now where they would be approaching some of the lowest temperatures in the modern record, because the sun right now is what astronomers call very quiet. There's not a lot of activity. So we can use that to sort of say, all right, this isn't a natural variation, because our natural variations were always thanks only to the sun, and then second, geologic and oceanic activity. So most of what we're seeing is from a cause that's not just natural. And then
Okay.
when we look at what humans modernizing have put into the atmosphere, and then you look at the science related to greenhouse gases and how that actually works, it all actually adds up. Greenhouse gases
So
make,
just quick
yeah.
interrupt. While you're on that, I want you to think about this first question.
Oh,
What happens if we cut fossil fuel emissions right now? So
Mm,
go back to your greenhouse gas question with that in
sure.
mind.
Okay. Sure. So when we talk about greenhouse gases, we're just talking about the gases that are emitted. Some of them were already in the atmosphere. They're part of our world naturally, but we've increased their concentrations, and we've increased their concentrations by, running engines and burning gasoline and burning oil and burning coal and things like that. And the way that they actually work is to rather than they don't really magnify the sun. So they don't make the sun seem hotter, but instead what they do is when the sun warms the earth, they prevent the earth from cooling down at night and during winter. So a lot of those temperature changes that we were describing, where it's getting warmer in the winter much faster than it's getting warmer in the summer, and it's getting especially warm. Um, the warming is especially fast during winter nights. Those actually line up perfectly with how we understand greenhouse gases to work. Uh, because
And
that's where we'd expect to see the warming first. So in that way, most of what I showed you, the vast majority of what I showed you in terms of the changes are not natural. They are because of changes that we've made in the atmosphere. Now, if if we were to stop emitting right now, or uh, it would, on one hand, that would be a, a huge benefit to the climate, but we'd have to be very patient. It would take a lot of time because there's already been a lot of time with a lot of modernization, with a lot of industry and a lot of driving and a lot of factories and a lot of power plants. And we've already put a lot of those additional gases into the atmosphere. So even
right.
if
I'm
globally
gonna
we just
introduce
shut
one more
down.
question
Yeah.
right now. We have one that says, we see a lot of articles circulating about the environment improving due to Corona. I mean, can we measure a climate signal from our lack of emissions this summer, spring?
So I think the first thing that we'll see is the people who do the monitoring in Hawaii, in Mauna Loa, who monitor how much of the greenhouse gases are in the air. They will probably see a, either a leveling off or a decrease in our emissions because we are using less. But it would take years, honestly. Uh, at least it would take more than it would take several years at least of this before we really even could detect these changes in the climate. And I think a big question for all of us is going to be, so when when this is over and people can go out and congregate in spaces together again, is everyone just going to pick up where we left off? Are we going to drive all over the place and fly all over the place and burn, burn, burn? Because if that's the if that's the case, then then the effect of everything right now on the climate would be pretty small. Negligible might be the right word.
Mhm.
Whereas if we can commit to keeping some of these changes, driving less, flying less, using less energy, maybe using less energy for heating those big spaces where people work, and for powering those. Um, well, if we can make some of those changes stick, then it would take a while because again, we've already done a lot of damage in the atmosphere. But we might start seeing some decreases in that damage in the years and decades ahead.
So, another student question. What would you say to someone that does not believe climate change is real? Or
Mm,
if it's real, that it's even an issue?
yeah, that's a very good question.
And what's the elevator pitch for that? Because usually they've already stopped listening before we start to answer that question, in my experience.
Yeah, yeah. I mean, there's a couple different things. So one is, I mean, I do a lot of work. Well, I used to before we were ordered home, but I would do a lot of work with people who maybe they'd invited me to come to their community and they didn't understand or they didn't accept that climate change is real. But in my experience, most people have a very hard time denying the kinds of changes that we've discussed today. And when they say they don't believe in climate change, what they really mean is they don't believe that we should do anything about it the way that they understand most people think we should do something about it. So they don't want to be told to change how they drive, and they don't want to be told to change their habits, and they don't want, especially a government telling them what to do. But if you remove that question and it's just about, yeah, but you have seen shorter winters here, right? You have seen it less less severely cold. You have seen more of those early growing seasons, right? You've seen more years where the flowers start emerging from the ground earlier, right? You've seen the ground get soft from thawed soils earlier in the year, correct? You've seen it later that you get the first freeze, right? You've seen more precipitation. You've all the things, and they usually will nod along and say, "Oh yeah, I've seen that." And so when it comes to the symptoms of climate change, I have found that almost nobody disagrees. But when you talk about what you're doing about it, that's where people have their disagreement. And a lot of people who say it's not real, I don't believe in it, that's what they're really talking about. It's hard for anyone who lives in Minnesota to deny that we've had massive changes in our winters over the last several decades. And
That brings me to Minnesota specific questions here.
yeah,
Ricky asks, how will higher temperatures affect water and fish? Are we seeing that already in Minnesota?
yeah, that's a great question. I'm not a fisheries expert, and I imagine there's a lot of people on this call who know more about fish than me. But what we're seeing, I can tell you generically that a lot of our lakes are getting warmer too. Uh, the lakes that are really shallow, and there's a lot of those in the northwestern third of Minnesota, especially
Mhm.
western and northwestern Minnesota. Those really shallow lakes do warm faster than the deeper ones because the deeper ones have greater volume of water. It takes longer, and there's a little bit more complex interactions in the water. I know that in terms of trying to save some of the cold water fish species, the DNR, in partnership with other agencies and other entities, has been trying to identify which lakes will still be suitable habitats for cold water fish species like Cisco, um, as the climate continues to warm, and then it's thinking about figuring out how to migrate the fisheries to those more suitable lakes, because we do know that the lake temperatures in general will go up at least near the surface, and it kind of depends on where the fish spend a lot of their time, depends on other attributes of the lake. But um, yeah, I mean, in general, fast changes in the climate aren't generally good for most natural systems because there's too many things that are dependent on it. And if the changes were more gradual, then it would be easier for a lot of these species to adapt. But when they happen rapidly, that's often faster than the scale of adaptation. It's a really good
Mhm.
question.
Then we have a couple of questions here about the connection between the tundra and permafrost melting and what
Mm.
that might mean for Minnesota's climate.
That's a fantastic question. Gosh, I'm just looking at these. One, I'm really happy at how many questions there are, and then two,
And I'm getting them privately as well, just so you know.
they're sure, they're good questions. Okay, so the tundra is off to our north, and you can think of this in two ways. One is, no, well, the easy answer is it affects us. It affects us because that's our reservoir of cold air. And so remember when I showed the map of Minnesota's warming faster as you go farther north? Well, that's also true as you go through Canada. Just keeps warming faster and faster the farther north you go. And the fastest warming of all is in the Arctic, is in the tundra regions. And so they're seeing very fast warming, and sometimes that's enough to melt the permafrost, and that releases a huge amount of methane, which is a greenhouse gas, which then furthers how much warmer the planet gets. So just that melting of the permafrost and the release of methane uh, would have an increasing effect on how warm Minnesota's winters are becoming. But the other effect is that as the Arctic areas, including the tundra, get warmer themselves, then whenever the wind blows out of the north in January and we're supposed to get really cold, there's less cold air because our cold air reservoir is less cold and has shrunken. And so it affects us in two ways at least. One is through actually melting the permafrost and producing more greenhouse gases. And the other is that it's just warmer in those areas now. And so they prevent us from, when the wind blows from there, it's just not as cold as it used to be. And that's where we get our cold air from. And I guess there's a third, which is that when the seasonal snowpack starts shrinking globally too, everyone on the call probably knows that the snow helps the air stay colder. And when you lose snow, when you don't have snow on the ground during winter, the difference can be 15 or 20 degrees Fahrenheit. And
Mhm.
so if the areas that get snow also don't have as much or any on the ground, then that also affects us. So yeah, it's a great question. Absolutely affects us in almost tragic ways.
Well, we are out of time. I want to thank you so much for
Yeah.
sharing with us. And if you wouldn't mind sending me the PowerPoint, I can look at some of those resources that we can share with students and in
Yeah,
the
sure.
classroom.
Yeah, I will. What I will do is I will post it on I'll give it a website. It'll just live there, and then you can access it and download it and use it. It's a little too big to email, but if you have an online system you want to use, you can use it. Otherwise anyone can access that link.
Okay, we've got one last question that came
Sure.
in. Do you think we are ready to take the leap to reduce fossil fuel emissions, or do you think that we will wait until the last minute to fix our mistakes?
Ooh, I think that's a great question, and I honestly think that most I think most Americans have not been ready, and even people who had accepted climate change and believed that something needed to be done about it weren't doing enough. And then they like to point at the people who didn't believe in it as the problem, but really it was all of us to begin with. My sense is that when given the choice, people will wait as long as they possibly can, and maybe till it's too late, and then they'll come up with some kind of a fast, maybe clever solution. I'm putting that in quotes because I'm not positive it would work the way a lot of us would like it to. But, you know, can I take an extra minute here,
I
Melinda?
think there's a reason I kept this question in,
Okay.
yes.
Yeah. I mean, I'm learning a lot right now about how decisions are made just by watching what's happening with the health issue. I'm not an expert in that, but I know that the people who are global health experts and study diseases have been saying, and they've been warning countries all across the world, and even the really wealthy ones like the United States, they've been warning them that this kind of thing was going to happen, that the population is just big enough and too interconnected, and that uh, and that it was just too likely, and we hadn't done anything to prepare. And and so now if you look at what we're trying to do to get, to manage what's happening, especially in the really heavily populated areas, um, or the areas that don't have many resources, it's all very much along the lines of, making the decision to do something a little bit too late, waiting till the last possible minute. And this is the exact same thing we've seen with climate change. They just happen on different time scales. The climate change is always going to be pretty gradual, and it's never going to sweep through every place at the speed of a disease. But we've seen the same thing where people tend to uh, put off making a big decision or a commitment as long as possible, and maybe even waiting until it's too late to do something, and then hoping that there'll be a clever innovation. I really hope that we learn enough from all of this right now that we do commit to making some big changes and that we don't have to wait until it's already too late. But we're pretty close to that point. I would be it would be dishonest for me to say that we weren't. I mean, the changes that we've already observed, that we've discussed, are big, big changes. They change the way the landscape responds, and they've changed the dynamics of the things that live on the land, and we're just at the beginning of this. So I don't want to end on a somber note, but I'm hoping that we'll see something different. But so far, I've seen that a lot of folks just want to wait as long as possible.
All right. And with that, thank you again.
Yeah, thank
And
you.
we appreciate you taking the time today to speak with us.
Yeah, wonderful questions. If you want to snap them out and send me them, I would do my best to answer them too if you wanted that.
Well, yeah, I can select. Okay. I'll,
Okay.
I'll see what I can do. All
All right.
right.
Well, but
Thank you
thank you
so
so
much.
much. Yeah, we'll be in touch. Thanks a lot.